Well, well, what has the cat dragged in today? It's another video tutorial on a stealth game. Now in this video, we're going to take a look at the enemy and start getting the AI set up on that. Now we're going to keep it obviously very simple. AI is just going to spin in place until it sees the player, and then it's going to run in a straight line to where it saw the player. And if it doesn't run into the player, it'll stop at its new position and resume spinning around. Pretty basic. Now, what do we need to do to get this guy set up? Well, first is we need a way of determining how it's going to get from point A to point B and avoid obstacles. And for that, we're going to need a NavMesh and a NavMesh agent. To get a NavMesh agent on our enemy here, make sure you have your enemy selected. Go to Add Component and type in Nav, and there it is, NavMesh agent. And there's a lot of settings that we can play with here. And there's only really two settings that we are going to potentially mess with. One is acceleration. This is what's going, or I'm sorry, not acceleration, speed. This controls how fast the agent moves. And we are going to want to change this speed to 5 so that the AI is at least as fast as the player. The other property that we're going to change on here is the radius. And we're going to change that radius down to 0.25, just like what we had for the player. We don't need the radius to be that large as it was with the default values. And that's really the only two properties that we need to change and worry about for this particular example. So that handles the NavMesh agent. How do we get the NavMesh? Well, first and foremost, you have to have the navigation window open. To get the navigation window, you go to Window, AI, Navigation, and that will open up the navigation window. I generally tend to like to dock it over here alongside the inspector. It's not a window that I commonly go to, and it's also not something that needs a lot of width. So I generally find this to be a reasonable docking position for the navigation window. Now we've got 4 options across the top here. The only one that we are going to worry about this time around is going to be the bake option. And there's this lovely little button down here called bake that if we click, nothing happens. All right, first, what is a nav mesh? And what does it mean to bake? In general, in game development lingo, when you bake something, you are generating static information in the editor that can be used at runtime. You generally bake things to improve performance. For instance, you might have heard the term bake the lighting. That's when you generate static lighting information that can then be used to make the level look nicer and perform much better. Same thing here. We are going to bake the navigational information. A nav mesh is just simply a polygon that is generated on the top of other polygons in the scene, other meshes in the scene. Now, the key word here that I've used is static. If you haven't marked geometry as static, Unity will not generate NavMesh information for it. And by static, I am talking this checkbox right here. It's a little bit confusing. You always have to keep in mind in Unity the difference between a static collider, which this floor here is a static collider because it has a collider component and no rigid body component, and a static game object, which means the static box in the inspector is checked. These are two very distinct things, and you need to make sure that you are keeping those straight when working in Unity. We need all of our level geometry to be static game objects. Now, if you followed along with the setup in the second video, second video. If you followed along with the setup in the second video, then you will have all of your level objects in a game object called _level. All we have to do is select that top level game object, pun not intended, and then click the static checkbox. Unity will then prompt you, do you want to change this flag for all children or just this object? We want to tell it, yes, change for all children. And now if I go through and look at these individual floor pieces and wall pieces here, they now all have the static checkbox on them. Now, if we go back to the navigation window and we click on Bake, hey, there we go. There's our NavMesh. Now, obviously, it's going to be generating a very simple NavMesh for our little level here. We'll generate a slightly more complex NavMesh once we move away from our test level and actually create a gameplay level. But, again, this will do it for now. So if you have your navigation window open and you're on Bake and you see this light blue overlay on the tiles, then your NavMesh has been generated correctly and you're good to go. If you don't see this, about the only thing that will cause this to not generate is if your game objects are not marked static. So make sure if you've got an area that is not generating, make sure that it's marked as static. And everything looks good on my end, so onwards we go. Now, the NavMesh agent will handle moving this game object around with the appropriate commands, but we still need to have some trigger volumes on here. Which means, since I need to have trigger volumes, I need to have a rigid body so that they can properly get updated in the system. Unity really doesn't want you putting colliders on a game object without a rigid body if you're going to be moving them around. So first, I'm going to add a rigid body component to this, and I'm going to immediately mark it as kinematic. I don't actually want physics on this. I just need Unity to know that, hey, this is a game object that has colliders and it's gonna move. Next, we're going to add some children objects here. We could just add some colliders onto the main top level game object here, but especially for this project, I really want to have visualization that's active while you're playing the game. And so to that end, I am going to right-click on Enemy, 3D Object Cube, which will create a cube as a child object. And I'm going to call this cube Vision. And what I'm going to do is I'm going to modify the scale on this. I am going to give it a scale of 8 on the Z. So that, in other words, this is going to be the detection range. I'm going to narrow this down. Oops, so it's not quite so thick. And I'm going to raise it up to about chest height here. To act as the sort of detection cone for this game object. And I want to make sure that it's right up against the chest. Now I'm also going to create, and before I move on, almost forgot, there's a property. We want this to be a trigger. So we're going to check this, mark this as a trigger. We don't want this to be an actual collider. Next, I am going to add a sphere. So I'm going to go back up to Enemy, right-click, 3D Object, Sphere. I'm just going to leave that one as is as far as the size goes. Basically, this is the area that if the player touches this, they've been caught. And we might, at some point, maybe we'll want to adjust it up to, a scale of 2. But for the moment, I'm just going to leave it as a scale of 1 and see how that behaves. I'm also going to rename this Detect, which is not the best. Okay, you could probably come up with a better name. I just don't really have a better, shorter name than Detect for this. Catch Detector? Yeah, no, I just call it Detect. And of course, I also want this to be a trigger. Now, it's going to be a little bit odd, to say the least, to have these like solid, opaque objects in the scene. So I want to apply some materials to these so that way they're a bit transparent. So I'm going to go into my materials folder in Assets. Again, doesn't have to be created in a materials folder, but it's good organizational practice. And I am going to right-click, create material. I'm going to call this the vision material. And just like we did with the Pachinko, I'm going to change the rendering mode to transparent. And for the color, honestly, it doesn't matter. Pick a color that you think looks cool. I am going to do sort of a green color here. The part that does matter is turn your alpha value down to 100 from 255 to 100 so it's nice and transparent. And then we can apply that to the vision cone and hey, there we go. Now we have this nice transparent vision cone. I'm going to apply the same to the feet here. I'm going to use a different color just to visually keep it straight in the editor what's going on. So I am going to Control D, duplicate, F2 to rename, and I will call this Detect Matte. And I will change the color. Again, the color doesn't matter. Choose something that you think looks neat. Because this also will help us in debugging if you can see where the detection radius is for the AI. Now I want to stress there's no particular magic as to why I chose a cube for the vision and a sphere for the end-game detection. Honestly, I could have used a sphere for both, although that would be one heck of a distorted sphere. I could have used a capsule, a cylinder, could have used a capsule or cylinder for the detection here, or even another cube. The shape doesn't matter. What matters is the idea of if the player enters the vision trigger, we'll move towards them. If the player enters the detection trigger, we end the game because they lost. That's what matters. Those two thoughts there. And I'm just going to double check to make sure I did in fact set these up correct. So this is a trigger. Yep, vision is a trigger. Detect is a trigger. Excellent, excellent. One last thing to do here on the setup that we will need for detection of the player. And that is a point to do a Raycast. Now, I'll talk about Raycasts in a moment. Just know that we need a point in which to originate a line from, and we need to make sure that that point is inside this vision detection area here. Now, here's a little handy cheat. I create, so on this vision game object here, I'm going to right click and create empty. I call this vision ray point. Now, when you do a empty game object like this, it's going to be placed at the center or the pivot point of the game object. So vision ray point was placed at the pivot point of vision, and the pivot point of a default Unity cube is the center of the cube. So this is now perfectly centered. I don't actually need it to be a child, so I'm going to break the child relationship there. It still needs to be a child of the enemy, obviously. It just doesn't need to be a child of the vision detection box. And then what I can do is just use the Z to drag it back. I don't have to worry about getting it super close to the player because, well, super close to the enemy, sorry. Because if the player is close enough to be inside of this point here, it's game over anyways because they've been caught. So I don't need to care that, yes, it is conceivably possible that a player could get so close to the enemy that the Raycast is going to fail. Because at that point, the Raycast is meaningless anyways. So, long-winded explanation for we need an empty game object that we can generate a ray or a line from in order to help us with detecting, can we actually see the player? Now, before we get to the code, I am going to make sure that this setup is easy for me to test. And yep, okay. At a distance of 8, this cone of detection goes through this wall. So I will be able to walk my character model up to the wall. And actually, you know what? Let's grab my player and make sure my player is looking straight at the wall. Oh, straight-ish at the wall. This way, all I have to do is run forward. And you know what? Give myself some time to get there before the rotation hits. All I have to do is run forward, and a few seconds later, the rotation's going to cause this to sweep through and hit me. I want to make testing as fast and as easy as possible. Iteration is the key for game development. That's how you get it good. And then I'm just going to do a quick overview of the enemy, both to make sure that I have everything set up correct, and to let people have a chance to verify that they have everything set up correct on their end. So, top-level enemy game object. Of course, the animator we set up a long time ago with our basic animation controller. We've added a NavMesh agent. We changed the speed to 5. We changed the radius to 0.25. Okay, that is good. I'll go ahead and collapse that. We added a rigid body component, and the only thing we changed on that was we checked, is kinematic. Okay, that's set up. Go ahead and collapse that. We then added on a cube that we set the scale to 0.5.58 and positioned it so that it's coming out of the chest. And the important part on this is that it is a trigger, and it is a trigger. We created a sphere. It is a trigger, and it's just centered around the feet. And then we created an empty game object. Switch to local, so this looks a bit more sensible. We created an empty game object that is inside, and this is very important, make sure that it's inside the vision cube. And yeah, that's an empty game object. There's not much else to say about that. All right, it looks like everything is set up. So before we close out this video, let's get some of the code started up, and let's at least get the rotation going before we start dealing with the nitty-gritty of generating rays and figuring out whether or not we can actually see the player. So I'm going to go to my scripts folder. I am going to right-click, create C# script. I am going to call this enemy controller. Open it up in Visual Studio. Again, pause the video here if you need time for Visual Studio to open up. And continuing on. Again, just like what we did with the player controller, we can ask ourselves some initial questions. It's like, okay, what do I need? What do I know that I'm going to need visible and ready for me in the inspector? Or what do I know am I going to need that is visible throughout the entire class here? Well, first I need to know my rotation speed, right? And that is something that I'm going to want to have in the editor. So public float rotation speed, and I'll give them the same default rotation speed as the player. I do not need a move speed because that's controlled by the NavMesh agent. I do need a reference to the animator component for controlling the animations. So I'm going to do the same thing I did with the player. I'm going to say public animator, and I'll set that up in the editor. And there's nothing else really. At least not that we can think of right now. Well, I'm actually lying. There's a couple of other things that we are going to be coming back in here and put in. I have a reason for not doing it right now. All right. So in the update, main thing that I need to do is rotate. And we already wrote out all the comments when we did the player controller version here. So I'm not going to do the whole comment thing again. Or I can be a very lazy developer and do the comment thing and do all of the other code just by doing a Control-C, Control-V. And realize that I called this rotation instead of rotate, which is easily fixed. That was easy. Now, be careful with copy and paste. It was a little bit tongue-in-cheek there, but legitimately, copy and pasting code can save you a lot of effort. There's two warnings. Warning number one, if you are copying and pasting the exact same block of code within the same file many times, you might want to think about converting that to a method instead of copying and pasting the code around. Because if you have the same block of code copy-pasted, let's just choose a random number, 8 times within the same code file, and you need to change that logic, you need to remember to change it in all 8 locations. This is a bug begging to happen. The other danger that you have to keep in mind, especially if you're copying and pasting code between 2 different files, is that you might have had some assumptions in the copy-pasted code that don't hold true for where you pasted it into, and or there might be variables that you have to change that you didn't change. So what I'm getting at, it's a useful tool. Be careful, it can also cause you a lot of headaches. But regardless, this is what the code should look like. Rotate amount equals input.getAccess horizontal. Scale it by speed and time. So rotate amount times equals rotation speed times time.delta time. And then finally a transform.rotate to get it to move. Save the code. Hop over to Unity. And we can test this tiny little bit of functional code. And then promptly remember that I forgot to actually add the code to the enemy. So let's fix that. So select the enemy, yeet that piece of code on there, go ahead and hook up the animator while I am thinking of it, because otherwise I'll forget that too. And I have made an error by going too fast. Honestly, I probably goofed myself up somewhere in here. Oh, right. You know how I was just going on about how there was going to be assumptions that might not hold true in copy-pasted code? Again, this is why I do my videos in one live take, because I'm going to screw it up at some point, and I want you guys to see those screw-ups. So, really, this is what it should look like. There's actually almost no point in doing the copy and paste. It was just a little bit of an impulse. Well, it's like, oh, hey, I can just copy and paste the comments and get the code at the same time. Actually, no, really, I can't. So this is what it should look like. Because I'm not basing the rotation of the enemy on input. I'm basing the rotation of the enemy on time and time alone. So I am always rotating. And I'm always rotating in the same direction. So rotation amount is going to be equal to my rotation speed times time.delta time. There is no getting of inputs here. Now we can hop back over. This is also the reason why, by the way, you should really be in the habit of, if you think you have a functional block of code, test it. Because if we had written the entirety of the code for the enemy and then it didn't rotate, well, where's the bug? I just wrote 50 lines of code. It won't actually be that many lines of code. But you know, I just wrote 50 lines of code. Nothing's working. Where's the bug? I just wrote 500 lines of code. Nothing's working. Where's the bug? So by doing these little micro compiles as is feasible, you can hunt down your errors a lot easier. And that is precisely what we expect to see. One last little tidbit of code before we leave off for this video. And let's get our on-trigger enter put in. Remember, using autocomplete is a great way to speed up your code and to make sure that you don't have errors. Now, is this trigger volume hitting things besides the player? Yes, it is. It's hitting level geometry. So how do we know the difference between the other in this on trigger enter, the difference between the other being the player versus level geometry or another guard for that matter? Well, we're going to use tags. Thankfully, there is already a tag set up that's called player that we can use, which is going to be quite awesome. So I can just ask the question, if other.tag, and again, it's always a good idea to head over to the documentation pages to take a look at this. If other.tag is equal to the string player, oops. To close things out, all we're going to do is print out to the console found the player. All right. Let's test this. As always, pause if you have to, if you need some more time to type stuff in. But heading over to Unity, hurry up and wait for it to compile. So it shouldn't say anything in the console when it hits the wall. And when it hits the player, it doesn't say anything. Now, this was an actual deliberate error this time. This is one of the absolute most common mistakes that I see people make when first getting into Unity. And that is forgetting to actually set the tag. So we have everything set up correct. And one of the ways that we can verify this is we could put another print statement here. Hit something. Hop back over. And sure enough, there we go. As it sweeps through all those game objects, we hit a bunch of them. And if I position myself right here, there we go, 32. Now it's 42, 43. So we know we're hitting. We know the trigger's working, but we're not falling into the if statement. And that's because if we go back and look at our player, the player still doesn't have a tag. Number one thing to check when you don't get collisions behaving the way that you think they should, check the Unity collision matrix. Do a Google search Unity collision matrix. It will almost always be the top result. Look at that chart. Actually, as a matter of fact, I did have to briefly pause the recording there. Unity collision matrix. Colliders, Unity, manual. Always make sure your version number is correct. Always, the first step in troubleshooting collisions is you always check this matrix. Should I get this message? Remember, the character controller is a kinematic rigid body. So a kinematic rigid body controller hitting a kinematic rigid body trigger, which is what that volume is, yes, we get a message. Great, awesome. Second thing that you always check when collisions are not behaving the way they should is make sure that any tags and layers are set appropriately. We're not messing with layers right now, but we are messing with tags. So just make sure that tag is set correctly. And yep, there we go, found the player. So now I know that my on-trigger enter is working as expected. So I'm going to get rid of this hit something. I don't need that message spamming around all the time. And with that, we are ready for the next video. Because this one's already a bit long in the tooth. So we'll handle the detection of, can I actually see the player, and then initiating the player chasing, and a couple of other changes that we're going to have to make to this code. As always, if you learned something useful from this video or you found it entertaining, thumbs up would be appreciated. If nothing value was gained, give me a thumbs down so I know to do better next time. And until the next video.